Hey, welcome back, Math Gurus. In today's video, we're going to learn about scientific notation, and then it comes directly from TEK 8.2c. It's introduced in 8th grade. All right, let's get started. So going back to 6th grade math, when we did 3 to the 4th power, it was a base of 3, and your power or your exponent was the 4. And the way you simplified it was 3 times 3 times 3 times 3, okay, which it would give you an answer of 81. Scientific notation is just an abbreviation for really big numbers or really small numbers. All right, so there's going to be a pattern. And so for the first one, it's 10 to the first power, which is just 10, and our value is 10. For the next one, 10 to the second power, or 10 squared, means 10 times 10, which is 100. For the next one, it's 10 cubed, or 10 to the third power, which actually means 10 times 10 times 10, which would actually be 1,000 when you multiply all three. For 10 to the fourth power, it's 10 times 10 times 10 times 10, and then that would actually give us 10,000. Okay, now if you're paying attention, you notice here there was just 10 to the power of 1, which you're not ever going to see that. 10 squared, then there's 2 zeros. 10 cubed, 3 zeros. 10 to the fourth power, 4 zeros. So in this case, it would be 5 zeros. And you don't have to trust me. You can work it out and check me. Put it in a calculator, 10 to the fifth power, you're going to get 100,000. Here, 10, you're going to have a 1 and 6 zeros. You could put it in the calculator, 10 to the sixth power, and you're going to end up with 1,000,000. Okay, for the next one, and I don't want to get too far into it because you get laws of exponent and algebra. But here, we can't have a negative exponent. 10 to the negative 1 power would be 1 over 10, and the value is 1/10. That's it. Now, here is 10 to the negative square, which that would be 1/10 times 1/10, which is 1 over 100. And then if you divide 1 by 100, 100 doesn't go into 1, so you'll add a decimal and 2 zeros, and then 100 would go into 100 one time. Okay, now for the next one, it's 1 to the 10th times 1/10 times 1/10, which is 100 times 10, which is 1 over 1,000, or 1/1000th, and then you divide 1 divided by 1,000. 1,000 doesn't go into 1, so you have to add some zeros. Put your decimal straight through, and then the 1 goes here. Now I'm going to show you the pattern. Okay, so, and you don't have to trust me, you can put it in a calculator, but if you have, because your first number has to be greater than 1 but less than 10. And we'll do more in examples. I just want you to see the patterns. Okay, so I'm going to start here because it's just 1, and I'm going to go 1, 2, 3, 4. Fill in the zeros, and I just converted it. And if you notice, there's a pattern. There's -3, and I moved 3 over. Here, -2, I moved 2 over. Okay. Now let's look at 10 to the fifth power, or 10 to the negative fifth. So what we do is we're going to go to the left 5 times. 1, 2, 3, 4, 5. Here we're going to go to the left 6 times. Now, you don't have to trust me. You can put this in a calculator and it'll give you the same answers. It's just easier way to do this. And some of you probably already noticed the patterns. Okay, so now let's convert, let's actually practice. So the first number, our first factor, so when you multiply 6 times 5, well, 6 is your first factor and 5 is your second factor. Okay, your first factor has to be greater than 1, and so, but it has to be less than 10. So here, I'm going to put the decimal after my first number, so it'd be 7.07. If I put it after the 0, it'd be 70, which would be greater than 10. And that's a problem. Okay, now in this case, I need to see how many spaces do I need to move. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this means 10 to the 9th power. So if you're like, wait a minute, I'm not sure, you would go 7.07 or 7 and 700ths and then go 1, 2, 3, 4, 5. Oh man, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to plug in zeros. Let's compare how I did it. There's 3 sets of zeros, go here. All right, I ended up back with the same original standard notation. This is called standard notation. This is scientific notation. Okay, let's go to the next example. Now, right now it's less than 1. So if I put the decimal after the 7, that'll be greater than 10, so that's a problem. So the decimal needs to end up here. Now, because it's a really small number, my exponent is going to be a negative. So 1, 2, 3, 4, 5. Now, 3.78 times 10 to the negative 5 power. All right, so let's test it out. If I did it right, it should work out and look exactly the standard notation. 1, 2, 3, 4, 5. There were 4 zeros in the original problem. Yep, we did it right. All right, now let's go to converting to standard. So what I've learned is this one's a lot easier for kids than the other way. They just forget to where the decimal goes. See, the decimal is 5.06. It's greater than 1, but less than 10. Because it's negative, that means I am moving to the left. Okay. 1, 2, 3, 4. Now, there goes my standard notation. One more. This is a positive. That means it's going to be for a really big number. Negatives mean really small number, and then positive exponents mean really big numbers. So what I'm saying is if the exponent is a negative, it's a really small number. If the exponent is a positive, it's going to be a really big number. It will always use the powers of 10. Okay, so 2.5, and then we're going to go 1, 2, 3, and so it's 2,500. Now, if you want to check me, you can do the math. 10 times 10 is 100, and 100 times 10 is 1,000. If you multiply 1,000 times 2.5, you're going to end up with 2,500. So it would be and like I said, I'm going from scientific notation to standard. Kids just do better at it. It's when you have to go the other way. So I just wanted to show how it works. Now, all right, this is the part where you don't want to forget. First factor is greater than 1, but less than 10. I would encourage you to pause the video and write this down. The second factor is always a power of 10, and the power of the exponent tells you how many places to move the decimal. the sign of the exponent, what direction. So negative exponent means move the decimal to the left because it's a really small number. And then a positive exponent means it's a really big number, so the decimal is going to wind up moving to the right. All right, well, I hope this helped. Thanks for watching.